take this time to demonstrate some of the concepts that I included in the lecture, namely what we mean by vector GIS and particularly a spaghetti data structure. So first off, vector is just a fancy term in GIS for drawing. In essence, it means an object, some kind of object that has geometry to it, that's located in a coordinate system. And so it makes reference to a standard coordinate system like we would use in the Cartesian plane. You remember where we have an x-axis and a y-axis, and there's four different quadrants. We think of like where both x and y are positive as being the first quadrant. Many of you have seen these kind of Cartesian planes in other classes. Well, GIS makes use of that same concept, and it's really important when understanding vector GIS. So a vector is basically just a drawing that has coordinates, and that drawing can be referenced to a location on the Earth in reference to an origin. So one of the most standard origins that are used to reference a location on the Earth involves longitude and latitude. And so longitude and latitude reference as their origin the intersection of the Earth's equator and its prime meridian, and we measure that distance around the Earth, since it's traveling along an arc, in degrees, minutes, and seconds, or alternatively as decimals or fractions of the degree. And so I'll be plotting this figure out, this vector. I'll be drawing this vector in terms of degrees, decimal degrees, longitude and latitude, again in reference to the equator and prime meridian. So here you're looking at some coordinates for a drawing, and this drawing involves three separate polygons. And so a polygon is basically just a series of arcs, arcs or lines that close on themselves, so that the starting coordinate is exactly equal to the ending coordinate, so that the object has an interior and an exterior. So here you could see this first value right here is a value for longitude. It has a negative value indicating that it's in the western hemisphere. The second value is the value for latitude. Since it's a positive value, it's indicating that it's in the northern hemisphere. And we could see that this is the beginning of the polygon. So this is the first coordinate for this polygon, and you could see that it's exactly equal to the values of longitude and latitude for the last coordinate, and so that it's a closed chain of coordinates establishing an interior and an exterior of the polygon. Here's the beginning of the second polygon and the ending of the second polygon. Here's the beginning of the third polygon and the ending of the third polygon. Again, since those coordinates are the same, the beginning and end longitude and latitude, it establishes that it is in fact a polygon. So I'm going to have GIS draw these coordinates so you can get a sense of what this looks like. So to do that, I'm using a special script that's no longer available, but it's useful for teaching purposes. Let me pull that up real quickly. And I'm going to insert this text file that we just looked at, enter some parameters, and give a name for this object. I'm going to call this object UIS and put it in my data file. And then I'm going to also tell GIS what coordinate system it's using. In this case, it's using what's called a geographic coordinate system. A geographic coordinate system treats the Earth as a globe. So it treats it as a round object. It's going to use, again, angular units, degrees, in this case, decimal degrees. And I'm going to say OK. And then say OK and let that run. And you could see here is that object that we just created. It spells UIS. And again, if we look down here on the right, you could see the values in decimal degrees of my area. And so if I put my mouse pointer on this upper corner, you could see that the longitude is negative 90.855. The latitude is 41.213 decimal degrees. And so these are those coordinates just pointed out. And again, since this object closes in and on itself, that it creates a polygon for each of the three letters, which establishes the three polygons. But notice, since these are in values of decimal degrees, longitude, and latitude, that they have a location on the Earth's surface. So I can pull up a base map in addition to that. Now, a base map is a raster. That's the other main type of GIS model. So let me open up the raster. First of all, I'm going to go ahead and remove this object temporarily. And I'm going to add a base map or a raster. And to do that, you just click on the Add Data button, next to it the drop down arrow, and choose Add Base Map. And then here you'll see that there's a bunch of different images. I'm going to choose this streets image first. And when I open that up, you'll see you get a rectangle picture. That's exactly what a raster is. It's a grid, and it's a grid of pixels. There's very small cells, and in each cell is stored a color value. And that color value, basically, since these pixels are small, our eye doesn't detect them, and instead it looks like a steady image. Let me pull up a different base map and show you the same thing. In this case, this is imagery. And we can turn this one off, and you could see this is again a picture of a map of the Earth laid out or rolled out on a two-dimensional plane. So let's bring back that object that I just created, the UIS object, which is a vector. Again, this is a raster. It's a rectangle of pixels. A vector is a drawing, and so I'm going to pull up that UIS drawing that I created. And you can't see it because it's relatively small. Those coordinates that I gave it basically had a known location on the Earth's surface, but is small relative to this map of the world. This is a very small scale map, meaning that it's 1 in 127,378,254. This is what's referred to as a small scale map. But let's zoom in. First, I'm going to color this into some nice school colors and say OK. And then I could zoom to this object that I just created, and we see that in fact that object spells out UIS in polygons. So again, let's turn this one off, turn this other one on. And we could see that this is kind of a reference map. Again, it's a raster. It's just an image. To get a little bit more clarity, I can add another vector image of the boundaries of the state of Illinois, because we see that this is in fact the state of Illinois. If I add another vector and say OK, and let's make this hollow and make the background the same color, and say okay, and I could zoom to this figure. And we see that, again, this vector drawing is the border or the boundary of the state of Illinois. UIS is that vector that I just created based upon those coordinates. So in essence, GIS is just a sophisticated drawing program, whereas your coordinates in the Cartesian plane map to a location on the Earth. So I could stick any kind of object anywhere I want. And again, all this is a sophisticated database where we're storing the coordinate system within the database. Um, so one other thing that I want to show you is that this is in fact a spaghetti structure in addition to being a vector format. So it's a